The moon, quiet, familiar, suspended above our heads night after night. We take its presence for granted, assuming it's just another rock in space. But what if that assumption is wrong? What if the moon is not just unusual, but intentionally placed? Or even artificial? This isn't sci fi. This is a serious look at one of the strangest and most enduring questions in planetary science. Is the moon a natural satellite or something much more deliberate? In the next 20 minutes, we'll explore geometry, geology, mythology, and modern science, examining the possibility that the moon is the result of purpose, not chance. Start with something deceptively simple: a solar eclipse. It's only possible because the moon is 400 times smaller than the sun and 400 times closer to the earth. The result? From our perspective, the sun and the moon appear the exact same size in the sky. This isn't true anywhere else in the solar system. Statistically, the odds of such a perfect alignment are incredibly slim. Coincidence? Maybe. But it's a coincidence that allows for total eclipses, crucial for studying solar coronae, advancing physics, and even supporting ancient agricultural calendars. Add to that the moon's nearly circular orbit and synchronized rotation, it always shows the same face to the Earth. Natural satellites typically have elliptical orbits and rotating phases. The moon's behavior, again, is oddly tidy. Without the moon, Earth's environment would unravel. The moon stabilizes Earth's axial tilt, keeping seasonal cycles predictable. Its gravitational pull creates tides, moving nutrients across the oceans, driving reproduction in marine life, even shaping coastlines. It dampens chaotic variations in planetary rotation, making Earth more hospitable over geological time. And it's not just science. Humans have tracked lunar cycles to measure months, influence crop cycles, and mark religious ceremonies for thousands of years. In short, the moon appears custom built to support life and civilization. Was that luck or design? So, where did the moon come from? The dominant theory is the giant impact hypothesis. A Mars-sized body collided with Earth 4.5 billion years ago. The debris formed the moon. Simple, until you look closely. Lunar rocks match Earth's mantle almost exactly. Isotopic ratios of oxygen, titanium, and tungsten are too similar for a random collision. Some rocks on the moon are older than Earth itself. Simulations struggle to recreate the moon's precise mass, orbit, and angular momentum. And if Thea, the impactor, existed, we should find evidence in the moon's composition. But we don't. The moon's formation story remains incomplete. Let's turn to myth and memory. Across cultures, ancient legends refer to a time before the moon appeared in our sky. The Zulu people described Earth before the moon where no tides existed. Bolivian texts speak of brothers who placed the moon in the heavens. Sumerian tablets describe gods setting the moon above. Greek philosophers referred to pre-lunar humans living without lunar influence. Could this be a metaphor? Possibly, but their consistency across civilizations suggests something more. Perhaps a genuine shift in planetary behavior observed by early societies. These stories do not confirm anything directly, but they persist, echoing themes of sudden cosmic change. In 1969, NASA's Apollo 12 mission crashed a module onto the moon's surface. What happened stunned scientists. Seismometers recorded vibrations that lasted nearly an hour. The moon, they said, rang like a bell. Later experiments produced similar results. Long-duration seismic echoes, low dampening, resonance unlike anything on Earth. Why? The moon is rigid, dry and brittle, lacking the water and porous rock that absorbs seismic energy. But even accounting for differences, the moon's behavior raised questions. Could there be subsurface cavities? Are there lava tubes or hollow zones? Is the moon's internal structure more complex than we think? Modern data shows a layered structure: crust, mantle, core, but its moment of inertia factor, mass distribution, and seismic echoes still leave scientists scratching their heads. In 1970, Soviet scientists Vasin and Shcherbakov wrote a paper with a provocative title: Is the moon the creation of alien intelligence? They didn't claim to know, but they pointed to patterns that didn't add up. Crater depth, large impact sites often appear too shallow. Internal resistance, something denser than expected may lie beneath the surface. Orbital precision, the moon's stable path around Earth resembles artificial satellites. They proposed that the moon could be a shell, covered in regolith to look natural, a possibility, not a conclusion. Western academia dismissed their work, but elements remain relevant. The moon's orbit is uniquely stable. Its influence is unusually beneficial. Its geological and seismic quirks resist full modeling. We don't see signs of technology, no panels, no transmitters, but the moon's behavior and proportions still defy expectation. Modern mapping reveals that the moon isn't uniform. The near side, the side facing the Earth, is smoother, thinner, and more geologically active. The far side has a thicker crust, fewer plains, and almost no maria. This lopsided distribution is still unexplained. Was it shaped by Earth's gravity? A second impact? Internal processes? Then come the mascons. Mass concentrations beneath lunar surface regions that distort spacecraft trajectories. And the lava tubes, giant tunnels beneath the crust believed to stretch for miles. Some scientists believe these cavities could shield future lunar colonies from radiation. Others wonder if they formed unnaturally. Engineered cooling systems? Subsurface voids? These are uncertainties, but together they point to a moon that doesn't behave like a typical dead rock. See you next time, here on Novus Universe, where mystery meets reality.